Hello, my name is Akhil Garg. Let me turn on camera. Hello, my name is Akhil Garg. I teach physics to class 11th, 12th, NEET, IIT, JEE, some dropper batches also in dropper engineering as well as in dropper medical. Today I am teaching you the topic photoelectric effect. It comes under the topic or it comes under the branch modern physics under the chapter of dual nature of matter and radiation. So today I teach you one topic. Please stay with me so that I'll explain you how I can teach. If you like my way of teaching, you can directly contact 8076 645 919. Okay. So here the topic or the branch of physics, that is modern physics. In modern physics, we can study photoelectric effect, matter wave, atomic structure, X-rays, nuclear physics, alpha particle, beta particles, gamma rays, photons, and radioactivity. Basically, we study in modern physics like subatomic particles which are moving with the speed of light. So what is the need of making the modern physics? Modern physics basically deals with microscopic objects, whether classical mechanics deals with macroscopic object. In classical physics, all bodies are moving with very low velocity, not with like speed of light. Okay, but in modern physics, the electron, protons, and subatomic particles, alpha particles, these are all moving with very high velocity, approximately equal to speed of light. Okay, so in this modern physics, we can study about photons that are packets of energy. But in classical mechanics, we study according to Newton's theory of gravity and use calculus. So basic mechanical laws are valid under classical mechanics. So there is a need of making another branch of physics, that is modern physics. So let's get started. So chapter name is dual nature of matter and radiation. Basically, radiation is made up of wave nature as well as particle nature. Radiation can behave both as well as wave nature as well as particle nature. Sometimes it is behaving like wave, like some phenomena, interference, diffraction, polarization of light, Huygens theory, and Maxwell's theory of light, electromagnetic radiations. So these are all consist of wave nature of light. These all explain how light behave as a wave nature. But the topic which I am going to start you today is photoelectric effect. It can be easily explained by taking light as a particle nature, because when one photon is incident, it get interacted with only one electron, not more than one electron or less than one electron. One photon gets interacted with one electron, so it is basically particle-particle basis theory. One photon get incident on the metal surface, the energy absorbed by the electron, then electron get excited from the metal surface, and this process is said to be photoelectric effect, which I am going to teach you in the next topic. Matter is also behaving like particle nature as well as wave nature. Okay, let us discuss some corpuscular theory of light. It suggests that light is a combination of corpuscles, that is like balls. When balls incident at certain incident angle, balls are reflecting at the particular reflecting angle. All the laws of reflections are valid. Angle of incidence equal to angle of reflection for perfect elastic collision. Okay, so this is like Maxwell's electromagnetic wave theory. It support only the wave nature of light. Yeah, Max Planck quantum theory, it explains the black body radiation that supported the particle nature also. De Broglie suggested that light is made up of photons. Like momentum of photon is h by lambda. Momentum of photon is given by h upon lambda. Energy is hc by lambda. Lambda is wavelength of the photons and h is Planck's constant. C is speed of wave. Okay. Next is de Broglie wave. De Broglie wavelength is like h upon p. Lambda is given by h upon p. P is linear momentum of the wave. Okay. So h is Planck's constant. So we can write it as E equals to hc by lambda to be E equal to P into C. Yes. So before studying the topic photoelectric effect, we have to study how electrons get ejected from any surface. As you all know that metal contains free electron. Metal में free electrons होते हैं. So metal contains free electrons. To eject the electron, we have to provide some energy to it. Okay. The source of energy may be heat energy. If you eject the electron from thermal energy, the emission is said to be thermionic emission. And when the emission takes place due to the electric field, the emission is said to be field emission. Third is photoelectric emission, which we have to study in our topic. Like by the incident of photons, you supply some energy to the electron so that electrons get ejected out from the metal surface. Okay, when a frequency of incident radiation is greater than threshold frequency or wavelength is less than the threshold wavelength, then what happens is there is a photoelectric effect takes place in which electron ejection due to the photons incident on metal surface. This process is said to be photoelectric effect. The electrons ejected from it are said to be photoelectrons. Okay. See here how thermionic emission is happen. Like a hot filament of bulb, when we get heated, it loses some electrons from it. When electrons get some energy, they are getting excited and escape from the metal surface. In field emission, you apply electric field, very strong electric field. When you apply, the electron experiencing force in the opposite direction of electric field, F equal to QE, because electric field is from positive to negative and force on negative charge of electron is from left to right. So F equal to Q into E. So now comes the topic photoelectric emission. When incident light of particular frequency falls on metal surface, electrons get emitted from the surface. See here, one evacuated glass tube is there. When light is incident on a collector plate is photosensitive plate basically. It is cathode. And here it is anode. When light is incident on cathode, which has excess of electrons, so electron get excited from it or ejected out from it. In the evacuated glass tube, electrons travel from cathode to anode and there is a formation of electric current, which you can say that photoelectric current, and the process is said to be photoelectric effect. Here is the Hertz experiment. Here, when energy of E equal to h nu is incident on metal surface consists of free electrons in it. When energy incident on the metal surface, electrons get excited out of it and they get sufficient amount of energy, that is Kmax. The amount of energy which is required to just escape from the metal surface is work function. What is work function? Work function is minimum amount of energy. Minimum amount of energy required to escape electron from the metal surface. Okay, so see here, E equals to h nu is the energy incident, work function is the minimum amount of energy required, and rest of the amount of energy is going into maximum kinetic energy of electrons. So basically, the energy of incident photons gets converted into two types of energy, that is work function and kinetic energy. Work function is the minimum amount of energy to eject the electron from the metal surface, and rest of the amount of energy left is going to be kinetic energy of the electron. Okay, so it is the work function is minimum energy, and with that work function we are taking maximum kinetic energy of electron. Okay, all electrons have not the same energy, that is kmax. Some very few electron or one electron have maximum kinetic energy, which has minimum work function. Okay, so by increasing the frequency, energy of incident photon increases, and with the increase of energy, what happens? Number of photoelectrons ejected will not changes. Means frequency is independent of number of electrons ejected per unit time, or photoelectric current does not depend upon frequency. See how intensity increases number of photons. What do you mean by intensity is here it is given that 100 photons are there, here given that 200 photons. You have increases the intensity basically. Here intensity is low, here intensity is high. When intensity is high, the photons are more, and photons are more, then more photons get interacted with more number of electrons. As you know that one photon is always interacted with one electron. So one photon get interacted with one electron, and 100 photons get less number of electrons. Okay, so photoelectric current will be more when intensity will be increased. But frequency is independent of photoelectric current. How? Because if you decrease frequency, that is like example 10 electron volt energy electron, and when you increase the frequency, the energy of electron is 15 electron volt. The work function is constant for both the metals, that is 3 electron volt. Like work function is 3 electron volt in 10 electron volt energy also, and 15 electron volt energy. Kinetic energy is 7.5 and 12 electron volt. Number of photoelectrons does not change by increasing the frequency. You can see that electrons, suppose 2 electrons are ejecting out here, 2 electrons are also ejecting out here. Frequency does not depend upon number of photons ejected. Okay, with the help of increasing frequency, you can increase the energy, and with the help of energy, you can increase the kinetic energy of electron, but you cannot increase the number of electrons ejected, or total amount of current, that is photoelectric current, is independent of frequency. So first definition is work function W naught or phi naught. So as I have teach you earlier, minimum amount of work or energy necessary to take free electrons out of the metal is called work function. The SI unit is joule and another unit is electron volt. What is threshold frequency? It is the minimum frequency which is required to eject the electron from the metal surface. Below this frequency, no photoelectric effect would be happen. Okay. What is h into nu naught? Nu naught is given to be hc by lambda naught. Lambda naught is threshold wavelength. Threshold wavelength is maximum wavelength basically. Okay. The rest of the topic I'll teach you in next video. Thank you.